over 10 years. And we're really happy as we've grown. We're now over 2,000 meetup members. If you recall or have been fortunate enough to go to AppSec California, you'll know that OWASP Los Angeles is one of the driving forces. And Neil Matatow and I were the originators of the conference, and we were joined by an unbelievable team of volunteers to help put that on for 7 years. We snuck one in right before the sequestration started. So we're grateful for that. Lovely community we have here in Los Angeles, great volunteers, a lot of really highly creative folks, a lot of good people sharing their ideas. That's what networking is all about. Everyone helps each other in their careers. And you know, before this COVID-19 mess started, we had 70 to 90 people typically meeting in person. Yeah, remember that, on the fourth Wednesday of each month. We would always have great speakers like Christiaan, and we'd have sometimes some introductory speakers, people who are, you know, hoping to hone their abilities, because we always support new and upcoming stars. There was always a great variety of people. And I want to give a shout out to my fellow Los Angeles board members, whose help was instrumental in many years of building this wonderful chapter that we have here, as well as you know, helping get sponsors and venues and food for all of you. Remember those days when you all had food? So just a shout out for a wonderful group of people that make me happy. That smile you see on my face is real, thanks to these folks. So thank you. Next meeting, and again, we always meet on the fourth Wednesday of each month. Now, November and December, we'll have to reevaluate because those are right up against the holidays. But we have Stefan, who will be speaking. So those of you who know him, he's got his own company, and he'll give a nice talk to us. He's quite a leader in the field. Do connect with us. It's great you're coming to these meetups. Obviously, you've already fulfilled the first line here because you're on our meetup. But we also have a company page on LinkedIn. We try to keep it relevant and share some good information. Yeah, we're still on Facebook. Of course, that's fraught with issues, but it's a good way for people to connect. We have our Twitter feed going on a regular basis. And for those of you who are under 30, yes, there is Instagram too. So please look us up there. There is an election coming up for the OWASP Global Board of Directors. I happen to be on the board today. I'll be finishing my first term at the end of December. All members can vote starting October 15th. If you're not a member, there's still time to join up, so you can cast your vote. It's only $50 a year. You're supporting a great cause. There are discounts for all global OWASP events. So if you go to one event, you'll get your money back. But more importantly, this money is going to help the cause for secure software for all of us. And that's really important, as you can see by all the breaches that are regularly occurring. I do want to take this one brief moment to endorse Haral Tsitsipas, who has been a co-chair with me for several years for AppSec California. What I have seen about this gentleman is an unbelievable dedication to OWASP and a take charge attitude. And he also has an empathetic feeling for all of us and all the people in the world. The board needs someone like Haral.
Could you spell his name so we make sure to vote for the correct person?
It was just on the slide. Are you following along on the slide?
No, I'm doing something else at the same time. I was hoping you could spell it.
Yes. So then, vendors, if you would like to join us and partner with us, we can help you reach a whole bunch of new potential people. If you're on this call, then it would be nice if you can connect with them. And one way to do that is through sponsorship of our meetings. You'll get some recognition in both website presence on our meetup site and in all the emails that go out to announce the meeting. So please do consider that, particularly during these difficult times. I know that it's hard for our business partners, our vendors to get a hold of people. There's no more in-person meetings, and it's harder for us to find you. So let's connect. Reach out to us through sponsorship.la@owasp.org, or find me, or go to any one of our social media sites. We'll be happy to work with you. Thank you. There is still some time that you probably have because of the lack of commuting. And so it's time to catch up on the AppSec California videos that are posted. You know, every year we spent a lot of money making top-notch, high-class videos for all of you to see, because AppSec California has 4 concurrent tracks, and you can only go to one. So now you can catch up on all of them. And AppSec California has earned its reputation as having the best lineup of speakers in the world over the past several years, even better than the global AppSec conferences. So that's your opportunity to learn from the experts. So please do consider, they're all up there on YouTube. It's now my great pleasure to introduce Christiaan. I want to thank you for joining us. He co-founded financial services security firm Intersect in 2009, and he's since moved to Google, where he's part of their security and identity teams. He's a frequent industry commentator on all areas involving cybercrime and cybersecurity, and he's also the co-chair of the FIDO2 technical working group inside the FIDO, which is the Fast Identity Online Alliance, and they're looking into standardization for strong online security protocols. Christiaan can tell us a bit more about himself, and we're just really happy to have him part of this meeting today. So Christiaan, welcome and thank you very much. It's all yours, my friend.
Thank you so much, Reg. Hi, folks. Christiaan here. I look a little bit different than I looked in that profile picture. I guess I haven't really been able to do anything about my hair, so I apologize for that. But
we'll send you scissors and a comb for that.
Or sure, is there something at this point? Yes, it's getting pretty well. I like your background, Reg. It looks like you're on a nice island there.
I am.
It's fantastic. Yeah,
I'm on my own island in my own mind, thinking about California.
I wish I was there too. All right. So with that, let's get started. I am very familiar with Google Meet, not so familiar with Zoom. So please bear with me here as I figure out how to get my own screen up. I think I just click a button, so that should hopefully not be too hard. Please do let me know when you can see what I'm presenting.
You're good.
Excellent. All right. So welcome, folks. Today, we're going to be talking a little bit about WebAuthn, the W3C standard that I guess we started on back in 2015. Before that, of course, came the FIDO Alliance, and I'll talk a little bit about like how W3C, WebAuthn, and FIDO Alliance relate to one another in a couple of background slides here. It's gonna get pretty technical. On the one side, there's gonna be a lot of user experience stuff, and then also, some code samples and some technical bits and bobs. This is a follow-on to the Black Hat presentation I did last year, where we just kind of introduced the concepts of WebAuthn and FIDO. So it'll really help if you're already somewhat familiar with those topics. Also, if you're not, you can always go back and go and watch that. I think it was part of the invite here is that link to the Black Hat presentation of last year. So today is kind of like we're picking up where that left off, and we're going to look at how you can use these standards today in your own applications to start your journey towards passwordless authentication. So with that, let me kind of do a quick recap of that presentation. I promise I'll only spend 4 or 5 minutes on that, and then we'll jump into the really new stuff. This slide will be familiar to anyone who's seen that presentation. Phishing is a problem, like we saw at some point, like phishing started to overtake exploit-based malware back in 2016. However, I thought, this slide is a little bit outdated, right? It kind of ends off in 2018. What has happened since? Let's look at this. I pulled this one this morning, right? This is from the Safe Browsing Google Transparency Report. Phishing is worse than ever. I let my mouse cursor hover over that March the 8th. It looks like, the phishers are very proactive in the whole working from home paradigm that we're all in right now. I'm not quite sure why we saw that incredible spike there, but point is that phishing is the #1 thing to be worried about if you run a website or a service that needs to authenticate users online. Phishing is like, it's really worse than ever. And I mean, I don't have to repeat the stuff that really happened over the last 2, 3, 4 weeks. We're all familiar with it. But as we know, in the news just a couple of weeks ago again, I think Krebs also wrote something about that very recently, where actually it was pretty good because FIDO and security keys were called out in particular as a solution to this phishing epidemic, right? I mean, or maybe it's a pandemic, right? That we've been facing here lately. So anyway, phishing still a problem. It's not only the old data; it also gets, really when we start looking at what's been going on lately, still big problem and something that we really need to try and address. So again, quick recap right before we jump into the new stuff. FIDO, and we'll look at what FIDO is in a second here, but in general, the FIDO protocol is a private public key scheme that allows users to authenticate themselves to a remote server, not with usernames and not with passwords, but rather with the presence of a private key, right? It uses public key crypto to authenticate a user. That's essentially in a nutshell, what FIDO is all about. The way this works is when you want to sign in somewhere, typically you might first enter a username and a password in the current system. And again, we'll look at some options here in a second, but you might start off by identifying yourself with maybe a username and a password. And once you've done that, the server is expected to send a brand new cryptographic challenge over to your device on which you're trying to sign in on. Think of that as a cryptographic nonce, right? It's to kind of thwart replay attack. So there is some challenge, some bit of data that the server sends that's fresh to your client device on which you're trying to sign in on. At that point in time, and here's the real, the real crux here of the system is the browser or the thing you're interacting with at that point. It can be an application, but let's, for the purposes of this discussion, think about that as a browser. The browser would look at who's calling. What is the actual URL that the user is seeing right now? And I'm seeing www.google.com. So that is actually going to be passed to what we call my FIDO authenticator here on the right. Now, in the old days, this was literally a physical piece of hardware, like a security key, the one you see there. In the new world, which we'll get into, this can be things embedded into your platform. It might be Windows 11. It might be the fingerprint scanner on your iPhone or Touch ID, I guess also on Android, right? So not only security keys, but in general, it's the easiest to explain FIDO using the physical security key because fundamentally the protocol stays exactly the same, right? So we pass in the challenge that you got in step 1, and we pass in the who's calling to the security key, to the hardware. And for that, we might use a local transport protocol like USB or near-field communication or maybe Bluetooth Low Energy. And at that point, we expect the security key to then sign that challenge and the who's calling with the private key that the user has on that particular security key. And what we're not showing here is at some point in time, the user associated this particular security key with their user account, with the server, and essentially a public-private key pair was generated and the public key was sent to the server. So what we're doing here is plain vanilla standard signing over a piece of data using this private key that the key has. We sign over it, we send all that data all the way back via the client, so via the thing the user is interacting with, their browser, on their phone, or their laptop, and we just relay all that data back to the server. What does this allow the server to do? Well, first, it allows the server to validate that the security key that it spoke to via the client is in possession of the private key that it expects, right? And it does that by, validating using the public key that it has, which is established previously. So that's pretty standard. But what's even more interesting, and I think this is the really interesting phenomenon here, and this is really what makes security keys and FIDO technology in general phishing resistant, right? The way that this works is the actual calling party, the URL that I was looking at, is also embedded in this response. And it was actually signed over by the security key, which means when the server receives this data back, it knows for a fact that this user was on the actual correct website that it expected the user to be on. If, for example, this user was on some phishing website, which kind of just proxied the real Google in this particular instance, that phishing website's URL would be embedded in the signature, and the server would be able to detect that and, of course, not process the login response. So in essence, what the security key does is it does two things. It proves to the server that this is the right security key that the user has in their hand. It's actually the one registered to Alice's account. All multi-factor technologies do that, right? However, it does one more thing, which no other multi-factor technology does, unless you're using smart cards, which, in a consumer environment, probably no one is using. But in that particular case, it also proves to the server which website or which entity the user was interacting with when they were trying to process the login response. So in other words, that's a mechanism for the server to detect whether the user is currently being phished or not. And I think that's kind of the crux, right, of the whole way that FIDO hangs together. And once we get into the more interesting kind of user journeys here, keep this in mind as kind of the basis on which everything else in FIDO or WebAuthn is built. Now, before I get started here, just a little bit of background on W3C and FIDO Alliance. I'm not quite sure how this usually works, but I think if this was live, in a physical environment, usually I'd be okay with people just putting up their hands, but here it's a little bit harder. So if possible, let's hold questions until the end. I think there should be more than enough time towards the end here to ask any of those if folks are interested. I think, we'll be going through a lot more content here in a second. So feel free to make a note or whatever, or type it into the chat box of Zoom, and I'll try to go through all of them if you're afraid that you might forget. Anyway, with that housekeeping out of the way, let's talk a little bit about WebAuthn. So FIDO Alliance started back in 2013. Essentially, a bunch of companies came together and said, hey, we have to solve this password problem and we have to solve this phishing problem. That was kind of like the two angles at which, from which we kind of like were pursuing kind of newer authentication methodologies, right? At some point in time in 2015, we said, well, we actually want to unify both of these two. It's not only about biometrics on the one side and phishing resistance on the other side. Let's unify both of these things together. And because the browser is going to play such an important role here, let's actually take the specifications to the W3C. So if you remember earlier in that picture that I've shown, there is a piece of the protocol that is between a website and your browser. That's in the W3C. And there's a piece of the protocol that's between your local machine, your laptop, and the physical security key, maybe USB, maybe Bluetooth, maybe NFC. That kind of stayed inside of FIDO. So that's really how we kind of split the protocol apart. Anything that a web developer would need to do is sitting over in W3C, while everything that a security manufacturer will need to do is sitting over in FIDO land. So with that, let's just quickly, again, look at that visually. Exactly what I said just now. Anything that the server, that someone developing a web application on the server side will need to do, they need to involve themselves with the WebAuthn API in the W3C. But if you are a security key vendor, you kind of look at the specification that the FIDO Alliance is publishing, and that specification is called CTAP. It stands for Client to Authenticator Protocol. And that's kind of like the marshalling of the, think of it, the bits on the wire between a client and a physical security key. So that's kind of like at a high level how these two things are split apart. So for the rest of this presentation, we'll mostly be focusing on the top end here, which is also why this is kind of, well, I guess the title could be more How to WebAuthn, since most of this is going to be involving the WebAuthn API. Although we do have an umbrella term to kind of encapsulate both the W3C spec and the FIDO spec, and this is usually called FIDO2. So FIDO2 is kind of like the upper, like kind of like the umbrella, kind of, unified term that we say this is FIDO2, and then under that sits the WebAuthn API, and this is just a different representation, right? The server to the client, which is my browser, my phone, my computer, and then there's maybe some kind of CTAP stuff happening to a physical authenticator. More interesting, there might also be some APIs to a local authenticator built into the platform. That's also reachable via the WebAuthn API, but they're usually proprietary APIs are involved. You can imagine if I'm using this on Windows, there might be some proprietary APIs between the browser and, let's say, Windows Hello on that platform, and that doesn't have to conform to CTAP, for example. So usually some proprietary stuff happening down here, but not really that interesting or relevant for the purposes of this discussion from a developer perspective. So let's kind of jump into all of the new content here today. So essentially, what we found was that there exists a gap between the spec, the current WebAuthn spec that's out there, and relying parties, or think of it as, developers, actually being able to implement the WebAuthn spec in the same way and the experiences that they want. The spec, the current WebAuthn spec, is supposed to tell browser vendors how to implement FIDO in their browsers, and it's also kind of meant to try and tell web developers how to implement WebAuthn in their own applications. And sometimes those two things are kind of hard to unify, and we've decided in the FIDO Alliance, we want to come up, and really in WebAuthn as well, we want to come up with a document that basically looks at this purely from the relying party or the web developer perspective. That document is called How to FIDO. It's open on GitHub right now. There's the link down below. Everything that I'm going to talk about today in this presentation over the next like 30, 40 minutes is coming directly from that publication. So if you gloss over anything here or something doesn't make sense and you want to go back, feel free to go to that URL. Feel free to look at the document there in detail. There's a lot more nuance and a lot more detail to that than what I can get through in a presentation here today. But essentially, that is kind of the document we came up with as, you know, examples almost to RPs, relying parties, of how to implement WebAuthn in their own applications when looking at this purely from a user journey perspective. Like, what is it that I want to try and accomplish here? What is it that I want my user to see? That document kind of does it, or at least attempts to do a good job at doing that. And also it's on GitHub because we'd love to take any like recommendations or comments or help. If you see another use case, if you have a different use case, feel free to help us incorporate that into the document. It's supposed to be a living thing. It's not quite published formally yet. It's still kind of evolving, but I think there's enough there at this point to actually try, or at least start to talk about this, I guess, in a bit more public forum. So essentially, please contribute to that document as well if you have interesting use cases that's not covered. But everything that we're talking about here today should be at some level inside of that document. All right. So with that, let's quickly talk about authenticators, right? So earlier on, also my example was geared towards a physical key, the thing I kind of hold in my hand here right now, the thing that we've spoken about when we talk about security keys. It's a physical key. It's something that I plug into my laptop over USB. Actually, in the latest generation kind of FIDO and WebAuthn specifications, we can roughly divide authenticators into one of 4 separate categories. The one that I've just held up in my hand and the one we were talking about earlier is the one in the lower right-hand side. This one, the phishing resistant second factor kind of use case. And then we see 3 others on the screen here. I'm going to try, starting from the top left kind of upper angle here, I'm going to try and talk through all of these just to kind of establish a baseline before we go into the rest of the presentation here. So today we have 2 types of or 2 types of authenticators. We typically refer to the roaming authenticator as a security key. We don't refer to a platform authenticator, which is like some authenticator built into a platform. Again, that's maybe Touch ID or Windows Hello or Android Fingerprint. We don't refer to that as a security key. Typically, roaming equals security key in the public or in the external manifestation here. However, for platform, we don't really have a good name like security key for that yet, and we'll go into some of the namings there in a second. But essentially, platform authenticators is authenticators that's built into the platform. Roaming authenticators is something I can remove from the device by definition, and I can plug it into other devices in the future. Platform authenticators cannot be removed by definition. They're built into the platform, they're baked into the platform, the keys are in the platform, and today there is really no way to get those keys out, right? They get established to the platform and they just stay there. Think of that as like, setting up your fingerprint for logging into your banking app on your iPhone or on your Android device, right? You use your fingerprint there, but when you get a new phone, you have to go through and establish, new fingerprint, like new setup all over again, because those keys never leave the device. That's kind of like what we're talking about when we talk about a platform authenticator. So now we have the definition for platform and roaming. Platform is built into the platform. Roaming, by definition, is not built into the platform. It's removable, something I can walk around with. Then we have on the, I guess on the other hand, on the left-hand side, we have 2 different types of authenticators. One is called user verifying, and one is called not user verifying. Very, very simple. Not user verifying is the type of security key I'm holding in my hand. That's a security key that doesn't, it doesn't care who touches it, right? Someone needs to touch the security key to make it work, but it doesn't really care who. There's no fingerprint sensor. There's no biometrics. There's no PIN code, right? You just plug the key into the port and you touch the button, and that's all you have to do, right? It's the, typical something I have factor, kind of a canonical example of that. anyone needs to just rock up with this thing, but hopefully because it's my key, I have it in my pocket, and then someone touching it, hopefully that would be me. But it's not validating that at any point in time. So that's kind of what the simple security keys are all about. And then if we now understand the platform versus roaming, and we understand user verifying versus not user verifying, then we can start to look at these different blocks, right? So let's look at what a user verifying platform authenticator is good for. And again, we'll look in each of these in much more detail here in a second. But if we start off with this, user verifying platform authenticators are really good for re-authenticating users to certain services. That's the example I just gave. I've got my iPhone or my Android phone. I'm installing my banking app. First time I use it, I type my username and my password, maybe do some 2SV thing, like maybe they send me a text code or something, right? I sign in. Then the app says, hey, do you know you can just use Touch ID next time you want to open up this app? And the user says, great, I want to do that. Next time they open the app, they can just touch their fingerprint and they're magically logged in. A platform user verifying authenticator is really good for that particular use case. And again, we'll look at that. Let's briefly look at the user verifying roaming authenticator, right? So that is a physical key that I can remove from my laptop. And when I rock up at a new device and I want to sign in there, I can now sign into that device, well, at least into a service on that device, let's say to my Google account or Facebook or Dropbox or whatever. I want to sign in there. I can sign in on that machine by using this as a very, very secure second factor, which is the experience we all know very well, right? You type your username, you type your password, you grab your security key and you push it into the drive and it authenticates you or into the port. However, it also has a different experience that we can enable. Because it is user verifying, it can identify the user, it can actually replace the something I know factor. The password that I traditionally enter can be replaced if I have one of these types of authenticators that can verify the user. Typically, these authenticators have a fingerprint sensor on them, or they need to be unlocked by typing in a PIN code, right? So once I unlock the authenticator by typing a PIN or by touching my fingerprint, I've already established my identity to the security key, and then the security key can establish, or at least establish its presence back to the remote server, also relaying that the right user was touching it, right? There was a match with a fingerprint. And again, no fingerprint data ever leaves the device. It's just locally authenticated to the device itself. Think of this as like a mobile phone where you've ripped out the fingerprint sensor in the key store and you've just put it into a USB device. That's essentially what this is. It allows you to go to any device that you want, a brand new desktop or a brand new laptop. You want to sign into a service on it. Okay, you can use it as a second factor, type username, type password, touch the key, or you can use it as a first factor. You just rock up at the machine, you insert your security key, you authenticate to it locally, fingerprint or PIN code, and then you assert your identity back to the remote service. No username needed, no password needed. The only thing you needed to do was have your key and locally authenticate to it. That's a new use case. That's one that we haven't really seen that manifest in a lot of places. However, as we'll see later in the presentation, that's something that's really becoming, I guess, more mainstream right now. The experience that we're all pretty familiar with, if you've ever used FIDO security keys, is the one on the right-hand side, on the lower level, right? It's a non-verifying roaming authenticator. That's typically what the security keys are that we buy today, right? You use it as a second factor. It can't identify the user, so you still need some other factor, typically the password, to identify the user. So the experience here is I go to Dropbox, Facebook, Google, doesn't matter. I type in my username, I type in my password, and then I insert my security key. By definition, it has to be removable because I need to log into different machines over the course of my lifetime. I will buy a new laptop. I will want to sign into Google on that one. I need to take my security key from my old laptop and plug it into my new laptop. So it needs to be removable to kind of satisfy that particular user experience. So don't worry if you kind of glaze over this a little bit, because I know I said a lot of different things. We'll look into each of these in a lot more detail in the presentation. But if you're ever interested in an overview, you can always come back to this slide that kind of just tries to talk about this all in detail. One, I'm going to omit. I'm not going to talk about this particular type of security key, the not user verifying platform authenticator. It's a very, very niche use case. There are some, it's typically the smaller kind of security key that you can almost think of like you put it into your laptop and you never remove it. I know this one can technically be removed, but think of it as you put it in and you never remove it, just leave it in the laptop pretty much forever. That one has a very specific use case, which is kind of more useful in enterprise environments. And towards the end, if folks are interested, I'm happy to talk about that in more detail. But for the purposes of the rest of the discussion, which focuses more on kind of like a consumer and I guess basic enterprise use, we're not going to talk about this one in too much detail today. So some high-level observations before we start. I guess we have started, but anyway, before we start with the real nitty-gritty, I want to kind of make a couple observations here, right? Long gone are the days of shared, library, like typical kind of computers for most users, right? Most of us have our own personal computers, especially like depends on the use case again, of course, right? But or also geography to a certain extent. But most of us have our own machines, right? And if you share it with a couple of family members, maybe there's like a desktop machine in the middle of the house, Mac, that everyone uses. But it's not like it's a machine that's sitting at the library and or at a university or at a college or at a school where thousands of users kind of track through on a yearly basis. So most of the time, if you're building a new service for users, you really should think about the lifetime of the session once a user is logged in, kind of as long-lived by default and not as short-lived, right? If you think about Google, for example, something that I can speak authoritatively about, right? Your Google session today, if you log into Gmail, Gmail is not going to time that session out. Like Gmail will, it'll take years before Google says, oh no, we really need your password for this session again. Because by default, we are assuming that users are using personal devices, or at least they're in environments where the device is shared with a small number of users. Of course, you can log out if you want. There's a button that says log out. We'll talk about what happens if you do that. But in essence, the experience is much, much better if you give your users by default long-lived experiences, and maybe you can give them the option, right? In some cases, there might be a little button that you can, or a box that you can uncheck, which says, hey, I'm on a shared device. Please don't keep me logged in here. Sure, you can go check that button if you like, or that box. By default, give the user a really long-lived session because it's just better for user experience. And you'll see a little bit later when we talk about FIDO why that's important. So of course, there are certain cases where that's not a good idea. Typically compliance, like if we think about financial services industry, your banking website, banking apps, maybe healthcare, there are some regulatory and some compliance issues sometimes where it's not possible to give users, almost like infinite lifetime sessions. But in general, unless you're falling into one of those specific categories, really think why it's not possible to give your users kind of longer sessions rather than the other way around. Now, if you can't leave your users logged in forever, let's say you're a banking app, you're a bank, right? At least remember that they've multi-factored on that particular device before. So in other words, if I sign into my bank on day one, I might enter my username and password and do some multi-factor ceremony, right? Maybe they text me a code, maybe they email it to me. I don't know, maybe I have to go to the branch, doesn't matter. I multi-factor on this particular device. Tomorrow I come back to my banking website, I need to sign in all over again, username again, password again. Really almost no reason to make the user multi-factor on that device again, right? Even if you've logged them out, keep the session information about the user that is multi-factored before, because if you think about MFA, what we're really trying to prove here is that a user has possession of a certain factor. The fact that they have logged in on that machine in the past kind of transitioned or blessed that device before. So you can kind of keep that blessing and allow the user to just come in with with just their password, because you already have that second factor as kind of like either in local storage or as a cookie on the machine, which really proves what you set out to prove, that it's the right user in front of the machine, which also did own some piece of hardware at some point in time. So that's kind of like the thinking here. Again, most financial services and other services that require multi-factor authentication actually already does it this way. I know there are some consumer services that doesn't, and it kind of always irks me a little bit when I interact with those, where you have to multi-factor on the same machine all over again. There's almost no good reason to keep doing that. Actually, that just puts users off from using multi-factor in the first place, and then they end up turning it off. So that's kind of like, high-level observation before we start. And it's not just because this is my preference. It also makes a little bit more sense when we delve into the deeper inner workings of WebAuthn, why this is kind of the framework which we kind of set out to reason about. So one piece of terminology, right? So account bootstrapping. What is this thing that I refer to? I keep referring to something called account bootstrapping. So bootstrapping applies when the relying party doesn't know yet who is controlling the client device, right? This is where I come to a brand new machine. I've just booted it up. I've never logged in here before to a service like Facebook or Google or whatever, right? The service has no idea who's going to authenticate at this point in time. They don't have a cookie that tells them some user authenticated here in the past. There's nothing, right? So at that point in time, we call this bootstrapping. These days, more and more, we are recommending that services deal with bootstrapping in a way where they don't put the username and the password on the same page, right? First ask for the username, then figure out what potential challenges you want to serve to this user, and then you're in a much more dynamic world where maybe you serve a password prompt, maybe you don't, maybe you have other authenticators. So the thinking here is, if you have to design a login page today, it's a good practice to kind of separate the username and then the other challenge prompts from one another, so you can kind of build these in dynamically. And this also might include account recovery steps, right? Maybe the user forgot their password or whatever, so you might want to challenge them with other things, like maybe you want to ask them their mother's maiden name, right? These things are all things you can then cover separately, but in essence, the recommendation is kind of separating things out. So you start simply with a username prompt and not the username plus password prompt, because obviously, with FIDO, we're trying to, remove the reliance on passwords. So here's our really first use case for WebAuthn, which any service today can potentially implement. This is the very simple use case, which we spoke about before, where I have maybe like today, the way this works is I have a mobile device, I log into my banking app the first day, tomorrow I come back, and tomorrow it just allows me to touch my fingerprint, right? What if we wanted to enable this experience on the web? What if we wanted to enable this experience on the web on my phone, but also on my MacBook, or also on my Windows 10 device, right? These devices and these platforms all have authenticators built in today, but without WebAuthn, there's really no way to wire them through so that the website can actually make use of the authenticators built into the platform. This particular use case is really interesting because a lot of your users already today, chances are, have devices and they're interacting with you on devices that have these capabilities built in. Windows 10 devices have Windows Hello. Android phones have fingerprint sensors. Apple just announced at WWDC that coming with, I think it was Safari 14, where by default now the platform authenticators on those devices, Touch ID and Face ID, will be wired through. So you can actually use WebAuthn to get to those as well. So chances are already you have a lot of users who can actually interact with their, they can interact with platform authenticators, and you can probably offer them a better experience in your web properties by using WebAuthn in this particular way. And essentially, the use case again there is first time the user logs in, type username, type password, whatever, but then the next time the user comes back, they simply have to touch their fingerprint on a sensor and they're magically logged in. So that's kind of like the experience we're going for, right? The way you can tell on a particular platform whether this is available, WebAuthn has a great, non-user interacting API, which you can call. It's very long. It's called is user verifying platform authenticator available. And if this returns true, you know your user is on a device with a built-in, a platform authenticator that can authenticate this particular user in the future. So it's a user verifying, if we go back to our matrix, it's a user verifying platform authenticator that's available on that particular device. The recommendation is once your user signs in with a username and a password, call this API. And if it returns true, give the user some kind of like a UI here. I showed you one here on the right, which is just a mock-up of something that uses the Google account, for example, that says, hey, maybe next time you come back on this particular machine, maybe you don't want to keep entering your username and password. How about you enable this feature, and next time you can just use whatever biometrics or platform capabilities is available to authenticate you. So that's kind of like the thinking, to just move your users, a very, very small step, but probably already a very relevant step for most of your users, into kind of the passwordless mode, where they don't have to keep typing passwords when coming back to the website. If you think about banking systems, right, pretty much every bank on the globe should be using this today because they keep asking you on the same machine to re-enter your password. So they could all make use of this right now, and it's already available, like I said, on the majority of browsers and platforms today. Here's a more generic way of showing that same thing to the user. Serve the user some kind of an opt-in page. Tell the user that next time they'll just be able to sign in using their biometrics on this particular device. And once the user consents and says, yep, I want to use this particular machine to just log in using a biometric, what you can then do is you can then actually go ahead and call the WebAuthn create call, navigator.credentials.create, and here is kind of a code sample. I'm not going to spend too much time talking through the code sample, but in essence, you kind of call this, and the most important pieces I've highlighted there in the comments, the most important pieces are, you want to say, I want a platform authenticator. I don't want something removable. For this use case, I want it built into the platform, and of course, I require user verification, because without that, you can't really get rid of the password. You have to identify the user somehow. Password was used previously. Here you're saying if the authenticator can identify the user with biometrics or PIN code or whatever, we can use that instead. So that's essentially how you can upstep your users today into a passwordless flow pretty seamlessly for services that keeps requiring re-authentication when you come back to the service after maybe 24 hours or 2 days or whatever the policy might be. Once you have established this key pair, which is what we've just done here, now we've created this key pair. We now have the key on the local machine in the platform authenticator, and we have a public key sitting with the service. Once the user comes back on this particular machine, all you have to do is you have to first remember on this particular machine that the user established a platform authenticator. So typically we say store that in some local storage, maybe store it in a cookie or wherever else you want to store it on that local machine. So when the user comes back next time to your web property, check if that cookie exists. Check if that cookie tells you that this user already registered the platform authenticator. And if they did, don't serve them a password prompt, right? Rather, serve them, on this one is kind of our implementation of this, rather when the user clicks on continue, serve them the navigator credentials.get call and actually just ask them to authenticate using the platform biometrics on this particular platform. So first off, we did create, we registered the call, or registered the key pair. Now when the user comes back, you check a local cookie, you say, yep, this user is on this current platform, they've registered a credential previously, we can now just go and we can just do a navigator.credentials.get. What's important again is that we pass in the actual ID of the credential we established earlier. That's kind of like a handle on the credential, which you can store in the local cookie or in some way, maybe with indirection, you kind of have that link to this particular session in a cookie. And then you kind of call in and say, hey, I need to, of course, user verification required again. I need to identify the user. I'm going to forego a password prompt. I'm going to offload user authentication to the authenticator. It's going to do user authentication for me, either doing a biometric or doing a screen lock or whatever mechanism the platform has to identify that particular user. So this use case, I think, is the one that's probably most relevant to the widest audience today because, as I said, users already interact with platforms that probably have this capability built in. And if you keep re-authenticating users because you're in the category of applications that need to do that for some reason, or maybe you have another reason for re-authenticating users, this is a very easy way to start making use of WebAuthn and give users a much, much, much better experience right off the bat. Okay, so that's kind of the one example, right? Using security key, or at least using platform authenticators to sign users in. And again, I skipped over one thing. I'll kind of just call it out briefly here, and then I'll go back. Just note that a platform authenticator is not a security key. I see this kind of error being made by relying parties sometimes, where they allow you to register your platform authenticator as like a security key. It kind of doesn't really make a lot of sense, right? Because security keys are meant to be removable. You're meant to be able to take it to a new machine when you log in. You can never take a platform authenticator to a new machine. So the idea here is that you shouldn't really manage and handle platform authenticators like security keys at all. The way you should present it to the user, we think, is rather through some kind of a dynamic opt-in, in the same way that your bank does it today with your app on your phone, where you just log in and suddenly it says, hey, next time, do you just want to use Face ID? Sure, like you just click I'm in. That's kind of the experience that we think for platform authenticators is the best suited for users today. Of course, there might be some edge cases where it might make sense in your property to actually maybe register a platform authenticator as a security key, but in general, I think this assumption holds. Like, it doesn't really make sense to register this as a security key and expect users to manage this in any way. Like, this should just be completely transparent to the user. They opted in at some point. The next time they come back to your property, they just touch their fingerprint and magically they're signed in. Okay, so let's look at the use case, which is the one that's kind of like rife through the industry today. Any property that uses a security key today likely implements it in this particular way, right? As we said earlier, the login flow we just shown previously doesn't fundamentally change the security posture of your user accounts. Why? Because if you go to a new machine, you're still going to have to log in with your username and your password all over again. And then again, it's going to say, hey, next time you want to log in on this machine, do you just want to use a biometric? You're going to say yes, and great. Now, as a user convenience aspect, you'll be able to just touch your fingerprint or whatever, but an attacker, for example, would still be able to break into your account using your username and your password. So it doesn't really change the security posture of the account, but it does give users a much better UX when they come back to your particular property. The easiest way to use FIDO to give you a phishing-resistant experience is actually to implement the ability for them to use physical security keys as second factors. Now, of course, the drawback here is your users will need one of these keys, right? And they cost money, and it's logistically it's hard, and you might not be able to make your users buy these keys. So we think security keys are very, very important, but probably for a very specific slice of users. Probably not for all, right? This is something where you have like maybe a user, a high-risk user, or maybe a power user, or maybe in an enterprise, right, where you can actually issue users with these keys. That's typically where having a physical security key as a second factor make a lot of sense. But in other cases, there are other solutions, which we'll talk about briefly, which I think better covers the generic consumer use case and how to make them a little bit more secure. So in other words, this experience is the one where, very, very straightforward. You folks probably know this from the way that Google implements this. You manage these things in your multi-factor authentication settings. If you have a Google account and you have multi-factor turned on, chances are you've probably seen this page somewhere where you can click Add Security Key. You get a security key, you plug it in, you press the button, and it registers it. And now next time you log into Google on a brand new machine, you're going to need to enter your username, you're going to need to enter your password, and you're going to need to grab your security key. And then the security key will do everything that we spoke about earlier, right? It's going to make sure you're interacting with the right Google website, you're not being phished, it's really you interacting with it, and then it'll allow you to sign in, right? So very, very straightforward experience. It's kind of the lower right-hand, a block of that matrix I've shown earlier, where you're using your security key as a second factor. The way you would do that, very straightforward. You'd call navigator.credentials.create, the same as earlier. There's loads more on the screen. Don't worry too much about the exclude credentials for now. But what's most important is when you're actually calling the create, you're going to say, I want a cross-platform authenticator. That means I want a roaming authenticator, right? I want something that the user can take from one device to another. Again, if we kind of look at this versus a platform authenticator, it wouldn't make sense to register a platform authenticator for this use case because it would be bound to the same system. You'd never be able to take it to a new device when you want to log in there. So you want to call cross-platform here specifically, and then typically what you'll see is some nice UI rendered by the browser that'll say, hey, you're trying to register a security key. Now go and grab it and plug it into the USB port and touch it. And then the browser will kind of take care of most of the interaction with the security key. So that's kind of like at a high level how you would set up a security key for account bootstrapping, which literally is what happens when you click on that Add Security Key button over here. When you click that, this is the call that actually gets kicked off. And this stuff that I said you don't have to worry about too much, the exclude credentials, you'll see here that I have a load of security keys registered to my account. Typically what happens when you click Add Security Key, all of those security keys are passed into this create call in order to make sure I don't accidentally register the same security key twice. That's the only reason for the exclude credentials. It's just kind of like a helpful hint almost to the API to say, hey, just don't register this same thing again on the same key, because that probably doesn't make any sense to the user. So that's really why we're calling the exclude credentials. And if you want more details of this in the How to FIDO document, we specify this in a lot more detail. So now you've created the key pair, right? Now, when you've done the create call, what pops out of the create call is a public key that the service, the Google or the Facebook or whoever now remembers for that user. Now, next time when the user comes back, and the user wants to sign into the particular system, you type your username, you type your password, and then you call the navigator credentials get. And again, this time you pass in all of the relevant security keys, and you kind of pass them in by using this thing called credential ID. You say, hey, this user has, if you count your 1, 2, 3, 4, 5, 6, 7 different security keys, we're going to pass all of them in here and say they're all valid for this account. And then browser, please figure out if the user has one of these keys. And that's essentially what will happen here, right? So the user sees the same UI as they see before. They need to touch their security key. And if everything succeeds, the website will get back a signature which matches what they would expect, right? It would match it, essentially a signature over the challenge, the origin, and then done with the private key that is held on this particular security key. So that's a pretty straightforward example. It's kind of the most uninteresting one, I almost want to say, because it's the one that's been with us the longest, right? This is very similar to also the previous protocol called U2F, which you know, we've been using at Google for quite some time. Briefly, I think this is kind of the last use case I really want to touch on in detail here. Oopsie, is the use case where we now allow you to use a physical roaming security key as a replacement for a username and a password. In the previous example, you remember, you type your username, type your password, and then you plug in your security key. Here we're saying, no, you need to do none of that. You just rock up with your security key, you plug it in. If there's more than one account on the security key that matches a particular website, it'll give you a list. The browser will give you a list and say, hey, I've got 5 accounts for Facebook. Which one of these do you want to use to log in? You click the account, touch your fingerprint, do it the other way around, doesn't really matter, and at that point in time, the user is magically signed in. So no username, no password needed, and the security key actually functions as both a first and a second factor. This is the first time we're actually starting to talk about really getting rid of the password. Because remember, in the first example, we kind of got rid of the password, but only when the user re-authenticates on the same device. Here, we're truly getting rid of the password, because the user can rock up at a new machine, plug in their security key, and just like touch their fingerprint, and they just be magically signed in. Now, again, as I said earlier, we don't expect a lot of users in the world to actually end up with physical security keys, even though they look kind of cool. We don't really think that's going to be, you know, the deal here. Mostly, we think users will end up using their mobile phones as roaming user verifying authenticator, so that you can just rock up with your phone at a website that you want to log in on your laptop. And magically, these two things would find each other. You touch your fingerprint on your phone, and hey, you'd be signed into your laptop or desktop without even needing to enter a username or password. I'll briefly talk about that. It's still, that part of the stack is still kind of a little bit in its infancy, but there's a lot of work that's being done on that particular use case right now. So that's the only use case that's not completely possible today. Everything else that we spoke about, including the one with physical security keys, is already implemented in most browsers, and the keys are on the market that can do all the functionality. So if you have a use case for this, this is something that you can actually go and use. So I'm not going to read through all of this in detail. I already said most of this stuff. I'll rather just quickly look at the actual code examples here. If you want to register this thing called a UVRA, or a user verifying roaming authenticator, which basically means the user now opts into a flow where they will use this instead of a password in the future to sign in, you know, maybe serve the user some kind of a register security key prompt, like the same one that we have on the Google account. You ask a user to click that button, go grab their security key, put it into the USB port, and essentially, when the user registers the security key, you make a call that looks very, very similar to the one we looked at for the second factor use case. The only difference is this time you say, I require a resident key. And a resident key essentially means that I need to be able to identify this user without giving any information to the security key. In other words, I won't have a username to give you a security key. I won't have a credential ID to pass you. I just want you to tell me what credentials for this particular website is on this key. So this is the first time that we're actually requiring the security key to store a bunch of stuff. We needed to store the username. We needed to store, like, of course, the private key. We needed to store a credential ID. We needed to store a bunch of different things which will tell the user about next time they come to use the key. So that's what resident key is all about. And then the second part is, of course, we need user verification, right? We need the key to identify the user individually, not just require a touch, but actually require the right user to touch the key. So a fingerprint, or like, you know, a PIN code might be another way to identify the user, but basically these two are both at this point required. We want to kind of call that out. And of course, still, Authenticator attachment remains cross-platform. We don't want a platform authenticator for this use case because the user would never be able to take it out of this platform and bring it to another device if we didn't specify cross-platform here. So, you know, I won't go into this kind of specific thing too much. How do you decide whether you want to do the second factor experience, which is what everyone's used to, versus the UVRA experience? There are some special recommendations and changes that we just made to the WebAuthn spec lately, which allows you to not have to make that distinction as a website. You can basically tell the security key or the platform, hey, I will support either of these. I don't really care. You just give me back whatever the key the user has in their hand. So if they have a more expensive key that has a fingerprint sensor and can do user verification or resident key, it'll tell you about that post the registration call, and you can then enable this user for passwordless flows. And if the user does not have one of those keys, they have an older type of key, or maybe a cheaper key that doesn't do all this fancy user verification stuff, at that point in time, you'll get that information back too. So then you can also register the key to the user's account, but you can keep using it as a second factor. So the user would still be able to, or need to enter it, both their username and their password, and touch their security key. So that's essentially what all of this is about. I won't go into this too much, but essentially you'll see here that the create call now looks slightly different, right? Instead of telling the system that I require a resident key and I require user verification, I say I prefer it, right? If the key doesn't have it, cool, it'll still work, right? But it'll give me back a slightly different type of credential. And then there's also one more thing here at the end, extensions cred props. It means kind of credential properties. And essentially what that says is, once you've created the credential, please also tell me what you ended up doing, right? That's what that extension means. It tells the website what we ended up creating. Did we end up creating a resident key with user verification? Did we end up creating a key without resident key? Without that extension, you just wouldn't know. So that's what was added to the latest revision of the WebAuthn spec, so that RPs can kind of request best effort. Just give me the best thing you can platform, and once you give it back to me, tell me what you did, and then I, as the relying party, will decide how to manage it. I personally think this is probably the best way to deal with UVRAs, because you don't really want to make it a requirement that you just go out and buy the most expensive type of key just because you don't want to enter a username and a password. Security-wise, entering a username and a password and using a security key is kind of almost similar to just using a security key with a fingerprint sensor on it in the first place. There's not really a lot of security guarantees that you get on the phishing side, at least. Like, both are equally resistant to phishing. So that's kind of the requirement, or at least the recommendation that we make. It's kind of, this is probably the way that you want to go about interacting with WebAuthn directly. As kind of a last, just a little blurb, I want to talk a little bit about registering phones as UVRAs. This is really where we see WebAuthn going, right? In the future, we want users to go to a website, maybe www.facebook.com or google.com. You don't see a username prompt. You don't see a password prompt. All the browser says is go grab your phone. You grab your phone, you touch your fingerprint to it, your phone tells you, hey, I have 3 accounts with Facebook on here. Which one do you want to use? You click on one, you touch your fingerprint to the back of the phone, and magically your laptop is signed in. So there's some communication, local communication, between your laptop and the phone, which kind of gets this information across from the phone to the laptop. But because the communication is local, we're also able to give you the same kind of benefits, the same kind of phishing protection that physical security keys can give you. So this is really the experience that we're think further down the line that we're trying to enable, because it doesn't matter how cool these things are, like these security keys that look like this, we just don't think that in general we'll be able to get like 1 billion users to carry these things around. However, chances are we'll be able to get 1 billion users to have phones. We already have that, and allowing them to use that phone then to log into other things, whether it's a laptop, whether it's a television, whether it's a dishwasher, it doesn't really matter. You can use the FIDO protocol then to ultimately get credentials from the phone onto the laptop, and no usernames, no passwords. All you need to do is just authenticate to the phone locally. The specification already has all of the bits to make this happen, at least the WebAuthn specification. What we're still working on is, in the FIDO side, what the actual protocol between the phone and the browser is going to be. That's kind of the more, I guess, I don't want to say interesting, but that's the more harder problem to solve. It's like, we know how we want to expose this to developers. We're just not quite sure yet what the actual specification is going to be like between the browser and the mobile phone, although a lot of work has gone into figuring that out. As you might know, Google launched a product about a year ago where we allow you to use your phone over Bluetooth as a second factor security key, and we got a lot of learnings on the Bluetooth side because of that particular product that we launched. So the idea would be that we take those learnings and then we come up with a solution together with other folks in FIDO, with something that we can then open up to third parties that will also give us the username-less and passwordless experience that we really want. So that essentially, in a nutshell, is kind of where we want to take FIDO and WebAuthn going forward. So anyway, I kind of skipped this. So registering the phone as a UVRA, I'm not going to talk about this too much. This is kind of more like, future type of stuff. But if you want to build a web property today, or you want to implement WebAuthn or FIDO, probably useful to kind of understand this use case as well, so you can build your product in kind of like a future forward way. So you can ensure that once this capabilities does become available on phones, that you can make use of it almost immediately. And you'll see that there's not a whole lot of like differences registering things over here. Again, we need the resident key requirement. We need user verification. The one thing that's different here is we're saying the Authenticator attached to this platform because we're registering the key on a phone, assuming that even though we're registering it as a platform authenticator, in the future it will be available over Bluetooth to other devices that they want to sign in on. And the way that you learn that essentially is through something that comes back in the response. There's this thing called transports, which will tell you whether the key is only going to be bound locally or whether it'll be available over Bluetooth or this special protocol we call cable, which stands for cloud assisted Bluetooth, which you'll be able to use in the future. So that, I guess, at a high level is kind of how phones will fit into this, although that piece isn't completely baked yet. Like there's still a little bit of work that's being done there. Although I'm saying both, step one that we looked at, or option one, option two, and the UVRA part, the physical security part of option 3 is already available, and websites can make use of that today. Signing in with the UVRA, I guess that's the only thing we missed. This is by far the simplest way to interact with the WebAuthn spec. You'll see here in a second. Look at that. I mean, it's really trivial, right? You do a GET call, but you pass in nothing. You don't pass in credential IDs. You just say, hey, I need you to tell me about all the valid credentials for this particular web property. And of course, I need user verification, right? Because I'm not going to ask the user for a password. I want them to just touch their finger and just be signed in, right? So the only thing you specify is user verification. Of course, you need to specify the usual stuff like challenge and RPID, but that's just like par for the course. But you don't pass in anything else. So this is kind of the simplest way to interact with the FIDO spec, where you sign in with the UVRA, whether it's a phone in the future or whether it's a fob today, which doesn't require you to pass in any additional data into the API. So I know I kind of went through a lot today, so would love to take any questions. I think one of the easiest things to kind of get started is Shane, who works with us on the FIDO side of things from IBM. He has a great website that he set up, howtofido.securitypoc.com, which actually implements the exact examples I went through today, and you can play with it, right? If you're on a Chrome browser, for example, maybe you're on a Windows machine, or maybe you're on like Mac or whatever, you can actually, or maybe on Android phone, you can go to this website and you can see all of these examples in action as implemented on his kind of like test server to play around with. He just said one thing I should just mention: there's no SLA, so if it goes down, hey, but I haven't seen it go down a lot. So if you're interested in kind of like experiencing this stuff in kind of real time, and also inspecting the code a little bit, like seeing what Shane is actually calling when clicking on various buttons, and it should hopefully match up very closely to what I've presented here today. So that's definitely the first thing I'll call out. Play with the FIDO server that Google has, WebAuthn.appspo.com, not as fully fledged as Shane's one, so I would prefer, you can kind of start here. This one is open source, so this might be a nice starting point too. The server-side code, so you can delve into that. There's a code lab that you can play with if you want to get started with FIDO and WebAuthn in general. And then lastly, I want to say almost the most important thing, the How to FIDO document, which is now this thing is over it, so now I can't show it to you anyway. It's just on GitHub. You can just Google GitHub How to FIDO. There we go. And that will kind of take you through in a lot more long-form copy through everything I discussed today, with a bunch of additional use cases that we didn't get to cover on the call here today. So that is it. I hope it was useful. And again, I know it's been a lot of information that we're trying to cram in here, but at least this should give you an overview of what's possible today, what you can do as a web developer. And if you have any questions, feel free to ask me now, or feel free to just reach out to me on Twitter. Happy to answer there as well. Thank you.
Thanks, Christian. All right, so I think we have a couple questions here in the chat. If you don't mind, I'll read them out loud if you want to answer them.
Sure.
All right, so the first question is, how can this be used with edge routers who are controlled by a self-hosted website, however, are on a private network without public access?
Oh, that's a great question. So none of the stuff that we looked at here today actually requires access to the internet as a whole. The only thing here is the edge router, essentially. Like, if the idea is that you authenticate to the edge router, instead of typing a username and password, you want to authenticate using a username, password, and security key, or maybe just a security key, or maybe even a platform authenticator. You can implement all of that directly on the edge router, but just as it has its own self-hosted website, you're going to have to basically implement a FIDO server on that edge router. It's not as hard as it sounds. That demo website that I spoke about, WebAuthn.com, where you can see the source code of a open source FIDO server. Essentially, that's where you'd start, right? You'd implement the pieces that you need on the edge router directly, and then all of the comms would be between your browser and the edge router. Nothing would ever need to go to the rest of the internet. Even in a completely offline scenario, you'd be able to authenticate using FIDO directly to that edge router. So you'd essentially just implement the FIDO server directly on the router.
Awesome. Thank you. I don't see any other questions here on the chat, but I guess I'll kind of open it up and see if anyone else does have any questions to ask. Going once, going twice.
Oh, I see one.
Okay, yeah, there's one more. All right, yeah. Can you replace passwords with a platform authenticator like Google, then pass to the personal FIDO authenticator to make sure it's the person?
So I'm going to try and answer the question. I'm not sure I quite understand the nuance here, but essentially the platform authenticator already allows you to identify the user individually, or at least a particular user, because the platform authenticator usually also offers the user verification option. Think of it as like on your phone, you have a fingerprint sensor, right? So it's actually identifying, it's not, my friend touching my phone, it's actually me, because you have that fingerprint component there. So you can already get rid of a password for a user that comes back to an application or a website on that particular phone or on that particular machine, because you have the user verification option available to you, and the user will actually be forced to authenticate themselves to that platform authenticator via fingerprint or whatever at the point in time where authentication is being asked for. You can wire up things in any way that you'd like. So for example, if you want to first have the user pass that, and then in your use case, also want the user to pass an external security key that they have to enter, obviously you can do all of that stuff. You'll just have to kind of tack it on, almost like serially, right? So you'll first authenticate the user using the platform authenticator, and then maybe authenticate them also, using maybe a physical security key. But essentially, like you can build on top of these use cases in any way that you'd like. But the platform authenticator already gives you the ability to identify the individual user because of the fact that they have the user verification option enabled because they have like a fingerprint sensor or maybe face recognition built in.
Right. I was just thinking about before you give somebody root access to a system, right, and it's a highly secured system, you'd want to maybe do both so that he has his fingerprint check as well as his plug-in security key using FIDO. Just wondering if it was possible.
Absolutely, yeah, great question, and that's kind of the part where I said like you can tack things on serially. So you can absolutely first do a GET call that says give me the platform authenticator, and only if that succeeds, do another GET call and then say give me the cross-platform authenticator as well. So totally possible in this particular situation to add as many of these steps kind of serially as you want. So yeah, definitely possible.
Thank you, Christian. Appreciate it.
No problem.
All right, it looks like we also received another question. I think the last two questions seem to be kind of related. I think it's more on just how do you ensure an actor hasn't stolen the phone? Is there a PIN code or fingerprint set up or something else in the FOSS?
Yeah, so that question I can answer like FIDO. So remember we had this EASE UVPAA call that we started off with, EASE User Verifying Platform Authenticator available. On a device that doesn't have a screen lock setup, that will return false today, like on Android. So for example, if you can play around with that website, I have WebAuthn.com. You can click, there's a button for EASE UVPAA that you can click, and you'll see if the particular phone is set up with a lock screen, it'll return true. If it's not set up with a lock screen, it'll say, nope, sorry, I don't have a user verifying platform authenticator here, specifically because of that issue, right? We don't want someone just picking up the phone if it has no lock screen to be able to do, FIDO authentication with it. So the user verifying platform authenticator on the phone is only available if the phone is actually secured with a particular lock screen.
Okay, awesome. Any last minute questions? All right. Well, thank you for your time, Christian. I appreciate it. I'm sure everybody else here does as well. We'll be posting this recording up on our YouTube channel on the OWASP LA YouTube channel.
Great.
And yeah, I guess everybody have a great day.
Perfect. Thank you so much. Thank you for the opportunity to share some of this with you folks. I really appreciate it.
Awesome. Thank you. Thanks, Christian.
Thank you. Bye-bye.